let's jump in straight away with a question about the degree of polymerization. So we talked about degree of polymerization being dependent on the species of trees and the pulping process. And we referred specifically to softwood and boreal trees. If, you know, basically the question is, when insulation is made all over the world, if it's produced using different types of pulp or different types of trees, pulping methods, how do you determine the degree of polymerization for those specifics?
So, yeah, thanks. Good question. So the degree of polymerization is the length of the chemical length of the cellulose molecule. The cellulose molecule is fairly a simple molecule. It's made up by a chain of individual monomers that are tied together with OH bonds. The test itself is actually a viscosity test where you take the cellulose, whether it's in pulp form or in a paper or board form, you dissolve it in a solvent according to the standard, and then you measure the viscosity of the solvent. As you can imagine, if you have a longer chain, it'll be a more viscous, thicker fluid. So there's a correlation that's done for that. We at Weidmann measure the degree of polymerization on the raw materials that we use. So as has been stated, starting with slower growth softwood trees, you end up with a starting degree of polymerization in the pulp form of around 1,200 to 1,600, and then it will go down as you make your board making process. Some of other trees, like if you were looking at the degree of polymerization of hardwood trees, that's a lower number, somewhere down around 1,000 to start.
Okay, thank you, Tom. We have a few short questions. I'm hoping you can answer them equally short. So one is on the topic of oil absorption. Is that a percentage of the volume or weight?
Brad, I'll let you.
I'll jump in here. So oil absorption is measured by weight. So,
okay.
So weighing the sample before and after the oil absorption.
Great, thank you. What is the optimal dielectric stress strength with press paper?
I'll hop in on that. That's not a simple answer to do, unfortunately. There are a lot of factors that go into the optimal strength. It depends on the design, the arrangement of windings, the clearances you have, how safe the end user feels about things. Some end users prefer a little more robust design. It depends on the material utilization, cleanliness of the factory, accuracy of manufacturing. So it's not a simple must be this number versus this number. There's a lot that goes into it. So quick question without a defined answer, unfortunately.
Thanks, Jason. How prevalent is methanol assessment with regards to determining paper life expectancy?
I'll take that one. So methanol is so there's, if you're looking at a transformer that's in service, we try to measure the insulation life by this degree of polymerization that I described earlier. The challenge is that if you have a transformer in service, you're not able to get a sample of the paper press board from the location that you want to test to do this viscosity measurement. So there's what's called markers in the oil. So as the paper starts to depolymerize, to age, some of the byproducts of the paper will end up dissolving in the oil. The most common test for that is called furans. There's a bunch of furan compounds that you can measure and correlate back to the DP. That has some challenges with some interference, and there's been some recent work done on methanol. Methanol is another degradation product from the cellulose. Our industry is fairly slow moving. I mean, this methanol measurement has been around for more than 20 years, but in the transformer industry, I would call it in its infancy. So a lot of research, most of it coming out of Hydro-Quebec and IREC, which is their research facility. But I know of 2 labs anyways in the US that can measure methanol and give you an estimation of paper degradation.
Okay, thanks, Tom. Brad, we have a question relating to slide 18. I don't know if you want to go to slide 18 and I'll ask another quick question while you do that. We've had a lot of questions about ester. Have we done the same studies with ester? So we've had a few comments. So the use of ester fluid may have different strengths. Will we comment on the effect of that? And we had a number of questions around ester, synthetic and natural esters, and specifically, can we consider high permeativity of oil for stress calculations? I don't know if someone can answer that one.
Yes, I'll jump in here first and just comment that esters, as I'm sure you're aware, have different relative permittivity values than mineral oil. So the numbers that were shown here were strictly for mineral oil, and obviously exchanging the insulating liquid will adjust those accordingly, both the relative permittivity of the oil or the liquid as well as the solid, and then these analysis would have to be done with those values.
Okay, my
Maybe I could
understanding
just
with that, Brad, is that we don't necessarily publish that data. That is something that we're currently working with individual OEMs on their specific design to provide a service to give that information or share that information with customers that they can contact us for more details on, if I'm not mistaken. Okay.
maybe
Yes.
if I can just add one thing. If you go to the slide before that, so we looked at the one before that, please. So we look at the property, the transformer oil. This is mineral oil. We see a relative permittivity of 2.2. For an ester, say a natural ester fluid, that relative permittivity is 3.1. So whoever had the question probably maybe knew that, but in that case, ideally you would have the same relative permittivity between the liquid and the solid. So certainly 3.1 is much better than 2.2. So in that case, we're able to put more of the stress on the solid insulation because we have a higher relative permittivity liquid. And when we share this presentation, there's some references. So there was a paper that actually I wrote, and it's in the references that talk about that.
Okay, Tom, and just one particular specific as you're talking about that, about replacing mineral oil with natural ester. With the higher permeativity and it's therefore closer to that of paper, is there an advantage or disadvantage relating to
It's
that?
an advantage.
Okay.
It's an advantage because whether it's ester liquid or transformer oil, the liquid is the weaker dielectric. So by having esters with a higher permittivity, you're able to move the electric stress into the solid insulation. So
Okay.
It's definitely an advantage.
Thank you. And then if we go back to slide 18, Brad, the specific question there was, how do we consider the RZ or RZ for the American translation as the geometry, not axis symmetry? How do you consider the model as the geometry, not axis symmetry?
Jason, I'll actually let you take that on the IDA as the IDA expert.
Yeah. So axisymmetric versus RZ for everybody else there. It's rotational in this case. What you're doing is you're picking the center of the core leg, which is not shown in this imagery. And I don't know who can see the camera, but if you have a core leg center and a coil, especially in a core form style format, they are round. In this instance, what we're doing is rotating it as opposed to a planar axisymmetric or planar, which would be as if it's two infinitely long parallel planes.
Okay, thank you. Question about the use of paper by manufacturers. So after Weidmann produces our paper, it's exported to a variety of manufacturers who control the installation process. Do we have any recommendations on how an end user may be able to determine that the insulation materials are applied correctly in the transformer design?
Yeah, I guess I can take that. If I was my recommendation, or the Weidmann recommendation for anyone buying a transformer, is that you should work very closely with your manufacturer. You can, to the highest degree, you can have a very detailed specification in which you specify specific raw materials that are utilized. And then I would recommend that you have either qualify the manufacturing plant, or if it's a very, some of these multi-million-dollar transformers, you actually do inspections of the unit as it's being manufactured. That would be the most reliable way to make sure that you're getting, a high quality transformer. And I'm sure there's, if you don't have the expertise in house, use a consultant. But to have someone that understands the manufacturing process, and then go on site and view these critical manufacturing processes, and one of which would be winding coils.
Okay, thank you. We had a couple of people asking about the Weidmann reference curves and whether we could clarify number 1 to 4 for the curves. So I'm not sure if you can head to there. But while we do that, Tom, I have a quick question for you that came in. So the dielectric strength of paper, according to the standard, depending on density and air permeability, is determined in air. How can you find out what the dielectric strength of paper that's been treated with oil is?
We publish strength curves in oil as well. And Jason talked to this a little bit at the first question about what the strength is of insulation materials. It's difficult in that you have to understand that the strength is measured according to a standard in a laboratory, and that strength is very dependent on the test method itself. In Brad's lab, he has different electrodes according to whether it's an IEC or an ASTM standard. And then also there's, as this question mentioned, there's tests that are done in air. There's also tests that are done in oil. And in most cases, the results are very tightly related to the electrodes themselves. So what you measure in a test according to a standard isn't exactly what you would apply when you're designing the transformer. But to finally come back to the original question, you should not use strength in air for designing a power transformer. And so I know for the Weidmann materials, we have tests in oil and oil-based criteria.
Okay, thanks, Tom. Brad, you want to comment on 1, 2, 3, and 4 in the Weidmann curve / line?
I can handle that one, actually.
Yes,
The 1, 2, 3, and 4 refer to the 4 different Weidmann reference curves for oil gaps. You're looking at insulated, degassed oil, technically clean oil on an insulated surface. You're looking at not uninsulated, degassed oil. You're then looking at insulated, gas saturated, i.e. in operation for many years without processing, and then uninsulated, gas saturated oils. So bare electrodes would be defined as uninsulated to a degree. So I hope that answers the question.
Yep, thank you. And we are going to have to wrap this up shortly. I apologize that there are so many questions still coming in, and we will try and answer all of these offline. Of course, we have a couple of questions relating specifically to Nomex. One of them, of course, comes from our friend Radek at Dupont. But I wanted to ask, so a couple of things. Would you advise if it would be an advantage or disadvantage if changing the insulation to Nomex, maintaining the topology and geometry? Was one question from outside of DuPont.
So there's been a lot of studies, and we've actually published in some of our transformer board books, comparing if we go to the stability of a transformer winding. One of the properties that Brad discussed and I reiterated in the summary was the importance of how elastic the material is, and that the radial spacers that Brad showed had, by removing the surface pattern on a cellulose spacer, you were able to approach 85% reversible compressibility. That is even much better, well over 90% with Nomex spacer material. So for short circuit strength in a transformer winding, Nomex spacer is better, and the Nomex conductor wrap as well, because it's such a high thermal class of the Nomex. You won't get any aging of that wrap, which causes it to shrink over its lifetime. So using Nomex within the winding itself will allow you to have a much more stable winding over the life of the unit.
And along those, or at least along the lines of high temperature, Tom, there's a question here that some studies show that esters can improve thermal performance of cellulose by 20 degrees, but Weidmann studies show it's closer to 10 degrees. Can you comment quickly on that high temperature topic, please?
Yeah, I can. I mean, I think that whoever asked the question showed we've done some recent studies. Actually, significant amount of the research we've done and published over the last 5 years has been on aging studies with different ester manufacturers, and consistently what we're seeing is that if you, in a sealed tube aging test, a laboratory test, if you use ester rather than mineral oil, you get a 10-degree better thermal class of the solid insulation.
Okay. Thank you. Just questions still coming in, but we will just ask a couple more, and then we will wrap this up on the hour. Quick question on thermally upgraded paper. Apart from the thermal stability, does it have any superior dielectric or mechanical properties as well?
That's easy. No.
Okay. Thank you for that quick answer. Let me question about offshore wind turbine transformers relating to solid insulation. Do we recommend a vibration test for that?
Yeah, that's an interesting one. I mean, Weidmann would not directly influence that because we're the supplier of the insulating material. My only comment is that, you know, if you go back to what Brad's presentation was, I would recommend, particularly if you have spacer material, that it's this milled spacer material. And then going back to what DuPont had mentioned, I think even if you wanted even better material for your winding, you could use a Nomex insulation.
Okay. Thank you very much. I think given the time, we will leave it there for today. We have a lot of unanswered questions, but we will work out how to distribute those between the three presenters and hopefully be able to provide you all with answers. Finally, I'd like to thank you all very much for joining us. It's great to see so many people and so much interaction. We really enjoy these sessions, and we will be back. We will keep you all informed of the next section. If you have specific topics that you think may be interesting for the wider audience, please feel free to drop us an email, and we will put them in a long list of of ideas and recommendations we've received. And with that, I would like to thank you all for joining us. Wish you an excellent continuation of your day wherever you are in the world, as we have people from all major continents on here today. So thank you very much from Weidmann Electrical. If you need any further information or would like to speak to Tom, Jason, or Brad about a specific issue or our engineering services available, then please feel free to reach out to us. Thank you very much and enjoy the rest of your day. Bye-bye.
Thank you all.
Thank you.